Assalamualaikum. My name is Ahmad Danial bin Muhammad Fauzi and my metric card number is CE180085. So today I'm going to explain the final year project 2 of mine, which is high voltage electrification system using plasma physics. So first of all, my supervisor's name is Dr. Nordiana Azlin binti Othman. Okay, she have been helping a lot on this project. So let's go through our content. Okay, so in this presentation we have introduction of the project, which is divided by 4 components, which is background study, problem statement, objective, and scope. Next, we'll look at methodology, which it will have 4 stages of the methodology in this project, and the results and discussion of this project, conclusion of this project. Alright, so in introduction, in this era, high voltage for electrification system is the main type of electrical energy used in a metropolitan area. This study proposes the idea to get an efficient environmental electrical energy system by using plasma physics energy source. A high level of service, which includes the terms of the capacity of consumers' use, the performance of the electrical appliances, and the quality of the electrification system itself, cannot be achieved. Alright, for the background of this study, plasma is a substance that is in a metal state. It was first discovered in the 1920s by Irving Langmuir. It consists of gas of molecules with an extra electron attached to the electron stripe. It generates when the neutral gas is heating and produces a strong electromagnetic field. An extra electron, which also known as free charges particles, is present to make plasma electrically conductive. A flyback transformer is proposed to generate the high voltage supply for the electrification system. The presence of a flyback transformer acts as a buck boost converter to form a high voltage power supply. Okay, next for the problem statement. First, we have disaster for land. By using the water dam, it will cause serious issue to the land, which is a flood to the nearby towns of the reservoir. Next, disaster for the marine life. It is interrupt fishes from the breeding ground, which cause the low population of the fishes. And lastly, high cost to develop a dam. The cost of a dam is similar with the cost to fossil plants. Alright, the objectives of this study or this project is to design the circuit to get maximum output voltage, which is 15 kilovolt AC. Next, to produce electrical energy by using the plasma physics concept. Alright, the scope of this project is using Proteus software simulation to design an electrical circuit with 15 kilovolt maximum output voltage by using a flyback transformer to achieve the study of the plasma physics concept. Alright, before we go through the methodology, we look at the plasma physics concept. What is plasma physics concept? Plasma is usually described as a fourth state of matter, juxtaposed with gases, liquids, and solids. This definition can hardly explain their main physical properties. Plasma can exhibit the behavior characteristics of all three more familiar states depending on its density, temperature. So we need to look for other salient characteristics. A concept view of the plasma model and the hierarchical structure of the plasma behavior that this project will cover. Alright, next, what is flyback transformer? Flyback topology is generally used to generate a multiple input isolated output power supply. The isolated power supply provides better accuracy and safety for other circuit components. Flyback converters require very limited external components such as magnetic components at the input and the rectifiers at the output. So we jump to the methodology. So we have four stages, which are the first stage is project planning, second is project modeling, third trouble testing and troubleshoot, fourth results and documentation. So this is the flowchart of the overall project, which the first stage have project title, um, literature review, project research of to make the project success. We have to do research by related journal articles and projects. Next, at stage 2, we collect the data from websites, study plasma physics with flyback transformer, different type of plasma used for the project, plan the generate the block diagram for the circuit diagram, and decide parameter at stage 3, types of flyback transformer, circuit test, and lastly collecting data. Okay, in first stage, the startup procedure begins at the commencement of the project. The project concept was debated and expanded upon during the process. The project is study about the effectiveness of plasma physics concept by using flyback transformer to produce high voltage electrification system. Next, in stage 2, project modeling. This project will proceed to stage 2, which this stage starts with the modeling. In this stage, the information from the research will be gathered to perform the modeling. Okay, at stage 3, the flyback transformer is performed to determine the output voltage, the type of flyback transformer, and all the components that used in this project need to be determined in order to testing the circuit to get the output voltage for this project. And lastly, result and documentation. Um, Documentation may be done at any stage in this project, so even after the project is complete, the structure of the project process can continuously coordinate and monitor project related actions based on the project milestones. Gathered data is accordance with the job friendly, the thesis reporting procedure will be completed. Alright, we'll look at the result and discussion. In this chapter, it will review the result of this project, which consists of demonstrates the block diagram, design circuit diagram, and graph output voltage. Okay, for block diagram, the illustrated block diagram of system that consists of 5 main parts, which is AC mains 230 VAC until flyback transformer, which output high voltage that will use for circuit development. Okay. Alright, before we go through the data, the result data that have been taken down, we'll look at the circuit diagram that have been designed in this project. So first of all, we'll see the converter, which is convert from VAC to VDC. So the value of the VAC is 230 volt with 50 Hz of frequency, and the output for this the output voltage for this circuit is 12 volt. As you all can see, here is the output for this converter circuit, which is 12 VDC. Alright, there also some there also a graph for this converter, AC to DC converter circuit diagram. Alright, okay, TR2, there is TR2, there is BA1, there also a C1 and A6. So this will represent the output voltage point, which is the TR2, BR1, C1 and R6. Okay, this is the graph which it's performed from 230 volt to 12 VDC. Alright, next for the converter, after the voltage go through the converter 12 volt, it will go through some components here until it reach the flyback transformer circuit diagram. This is the flyback transformer circuit diagram, which we have NPN transistor, resistor, and also MOSFET. And this the most importantly is the MOSFET and the the transformer here. So we'll run the simulation. Okay, as you all can see, the output voltage AC that will be taken down is at kilovolt. So as you all can see, it will gain from just now from 5 kilovolt. It will slowly gain until it reach to 15 kilovolt, right? All right. There also the TR1. TR1 is from primary coil of the transformer, and this is the output for the at the secondary coil of the transformer. Okay, for the result circuit diagram, this is the circuit diagram that have been designed by using Proteus 8 Professional simulation, proving the circuit development process that been discussed before. The function of this circuit is to troubleshoot the system before hardware development in the future. So this is the full circuit diagram of this study, which the combination of 12 VDC circuit diagram and the buck boost converter with output 15K VSC from the observation the study performed and achieve the first observation. Alright, for the graph result, the result from the circuit 12 VDC and proof that the voltage at the 230 VAC convert and step down to 12 VDC. So over here at right hand side, the graph of output voltage 15 kVAC. In this study, the voltage needed to trigger the circuit buck boost converter is 12 VDC. Then the result of the graph appeared from 5 kVAC, and it is gained slowly and until it reached 15 kVAC. Alright, for the conclusion, the project is done by referred some of the resources that have been found from the previous thesis. There are some troubleshooting on the design circuit diagram to make the study achieve all the objectives that have been pointed out. The result 15K VAC that achieved is based on the succession of the designing the circuit diagram by using Proteus 8 simulation software. The existing of flyback transformer in the circuit diagram shows the gaining of the voltage from 12 VDC to 15K VAC. In addition, the flyback transformer itself makes the plasma physics concept is applied in this study. So for the future plan, this study is for high voltage application. Technology is changing and improved through time. The recommendation for future work is to use sustainable energy such as solar energy to supply the power build the electrification system using plasma physics concept. Moreover, for designing circuit, this project encourages to use the exact flyback transformer device in Proteus Professional instead of designing itself. Alright, that is all from me. Thank you.